One of the most important basic things that the electronic tube can do remains yet to be listed. Besides transforming light into electric current, it can also transform electric current into light. The cathode ray tube is an application of this property. Through the aid of this tube, an electron beam is able to recreate an original image on the screen of a television receiving set. The electronic X-ray tube indirectly also transforms electric current into light, and by its effect on photographic plate, into light images. Here's how an X-ray tube works. A high potential ranging up to 300,000 volts or more is applied between the anode and cathode. Electrons are emitted by a focusing cathode. Due to the extremely high voltage, the electrons hit the anode with tremendous impact and cause the emission of waves of exceptionally high frequency. These high-frequency waves do three useful things: penetrate, excite fluorescence, or affect photographic plates. As a result, doctors can now study human internal organs by means of the fluoroscope. Or by means of radiography, they can photograph them. Industrial X-ray today is also playing a vital role, detecting porosities and fissures in welded metal seams, examining heavy castings for invisible internal weaknesses. But X-ray isn't the only example of electronic usefulness in the conversion of current into light. The whole field of modern fluorescent lighting represents another application. So does the field of ultraviolet radiation. Harmless-looking tubes like this one have a deadly effect on bacteria and other forms of microscopic life. In this demonstration, Parmesia rather than bacteria are about to be subjected to Stereolamp rays. Notice what happens. The Stereolamp today is becoming increasingly important, both as a servant of public health and as a device for the preservation of perishable goods. So many and so varied are the applications of electronics that a single film like this can mention only 1 in 1,000. We haven't even mentioned, for instance, radar, the electronic development that helped save Britain during the decisive weeks of the German aerial blitz. Here's what happened. Ultra-high frequency waves were broadcast into the skies from English defense stations. When enemy planes approached in the darkness or in the fog, these waves would reflect back to the transmitting points, thus giving warning to the defenders of Britain, permitting anti-aircraft batteries to swing into action and RAF planes to rise for combat. Whenever Hitler's bombers attacked, at whatever altitude, from whatever direction, British interceptors were waiting for them. As a result, the Luftwaffe was blasted from the English skies and the tide of war turned. Yes, the electronic tube, in essence, is only a switch. But what a switch! It rectifies, amplifies, generates, controls, transforms light into electricity and back into light again. These tubes that look so mysterious are essentially simple in operation, incredibly rugged and sure in application. They open and close all forms of electronic circuits as swiftly as the lightning flash and as silently as the passage of time. In the world of today, they're helping us to win a war. In the world of tomorrow, they bid fair to lift all of us to new levels of achievement, comfort, and security.